Thank you, QX. Now that you have learned about machine learning algorithms, I'll explain how you can detect covert channel using chaos theory. Now, chaos theory tells us that there are often certain laws behind seemingly random systems. Glenn has explained in the previous slide how you can construct a TCP/ISN based covert channels. And as you all know, these ISNs are generated by pseudo-random number generators. These pseudo-random number generators exhibit a chaotic behavior. Now, to understand this chaotic behavior of ISN, we use phase-space reconstruction method. Now, what is this phase-space reconstruction method? It's a very useful non-linear chaotic signal processing technique by which we can reveal the nature of a dynamic system like pseudo-random number generators here. What happens in phase-space reconstruction is we describe a dynamic system by a multi-phase diagram, which is nothing but a multi-dimensional coordinate system. The question you are thinking is which dimension we should use here? Two-dimensional, three-dimensional, maybe more. For testing purpose, initially dimensions of 2 to 6 were used, and it was found that dimensions 4 and above gives 100% accuracy in detecting ISN-based covert channels. But larger the dimension, the larger is the complexity of the algorithm. This is how ISN-based structure looks in 3 dimensions. As you can see, it reveals some kind of structure and relations among ISNs. Now, to extract meaningful data among ISN, we pass it through a 4-dimensional data based on chaos theory algorithm. Now, this is the algorithm which has around 9 steps. It seems like very abstruse in the beginning, but I'll demystify it step by step with the help of an example. For chaos theory, we have to use around 350 legal ISNs packet to get 100% accuracy. But here I have used 25 ISNs. The first step is to plot these ISNs in a 4-dimensional data. So, using the left part as a base, we calculate the coordinates of these ISNs in 4 dimensions. Now, you see, we have created 5 vectors in 4 dimensions. Once we are done with plotting in 4 dimensions, we have to calculate the distance between each pair of vectors. So, a vector of m size will give you an m cross n matrix here. You will notice for each vector I, if I is equal to j, you will get the distance is 0, because the distance of a vector to itself is 0. Once, and by the way, this formula in the lower section is used to calculate the distance in 4 dimensions. Once we have the m cross n matrix of m rows, we can calculate the variance of each row vector. So a matrix of m cross n size will give you a variance vector of m size. Here the mu part is the mean of the jth row, and dji is the distance between the vector j and I, and n is the size of the vector. Once we have the variance vector, we can calculate the higher order statistics, which means we again calculate the variance. So this is the variance of the variance vector. So in the previous slide, we have 5 variance values. This variance underscore sigma is the variance of the variance vector, so which is a very large value. And this is important here because this is used as a threshold value to distinguish the legal practice as well as the illegal practice. And as I told in the beginning, this is a legal ISN based variance vector value. And which, if we divide it by 10, we get the threshold value. So if we are doing testing on the incoming sequence of packets, if the threshold of those packets is less than this threshold, it means that the packet is purposely modified and created using covert channel. But if the threshold of the testing packets is more than this threshold, the packets is accepted. So this is it. This is all about chaos theory, and it has certain advantages, like it is efficient. Efficient as in it gives us 100% accuracy in detecting ISN-based covert channels, and second, it is less complex. Less complex because it uses only 350 legal packets, whereas in case of support vector machine, we use both legal as well as illegal packets, and that too in thousands of numbers. Third is, as it is less complex, it requires less computational power, so it can be used both online as well as offline. So this is it. If you have any questions, you can ask.